I'm speaking here for the next several minutes with Dan Batcheldor. He has a Ph.D. in astrophysics and is working on an interesting project that I thought our listeners and viewers might be interested in helping to support, but also to sort of see what it is whenever it does finally release and come out. So I've asked Dan to join me here. Dan, it's good to talk to you. How's it going, man?
It's going great. Thanks, Seth.
That's got to look good on a resume. Astrophysicist, right?
It has helped me out so far in my career, yes.
Tell me about your career real fast. Let's do kind of a quick resume. What's some of the stuff you've done?
Okay, so I got my PhD from England, as you can probably tell, just outside of London. Got that in 2004, and then moved over to the United States because, well, quite simply, there's more jobs for scientists in the United States. And then moved to Florida in 2010, so from upstate New York. So I'm sympathetic to those people that have got weather troubles.
Now, aren't we behind the curve science-wise? Yet there's more science opportunities here in the States?
Well, this is where the money is. So this is where we have a lot of opportunities to get people jobs. So there's a lot of money that comes through NASA, that comes through the National Science Foundation, that actually supports young scientists starting their careers.
You've done some work with NASA in the past or currently?
Yes, that's right. Working with NASA and actually being funded through NASA. So the taxpayers' money gets to scientists through NASA. So we, as scientists, we write to NASA and request money to do our research. And then NASA will actually provide us that money to get that done. And then, of course, we're just down the road from the Kennedy Space Center. So we work with NASA quite a lot on a lot of the projects that we do here.
Dan, I was talking to Carolyn Porco. Dr. Porco is part of the Cassini mission project and has been for a long, long time, you know, the exploration of Saturn. And we were just speaking off the cuff at a conference in Canada. And I'd ask her about the budget challenges. You know, if you're doing this type of work and you see so much money being funneled into so many other things, and yet many people sort of cast space exploration and the work that NASA does, which goes far beyond missions to Saturn, et cetera. They sort of cast it off as a waste of funds, a waste of time, a waste of resources. You want to address that at all? I mean, what's your take?
Oh, sure. This is a common criticism when people say, why spend all this money on space exploration when we have all of these problems here on Earth?
People are starving all across the planet, Dan, and yet we want to leave this planet and go focus our efforts and resources elsewhere. You hear this quite a bit.
That's right. Yeah. Now, it's important to realize that we're an exploration species. The reason we're technologically advanced right now is because we have pursued scientific endeavor. There's a reason why we can do a Google Hangout now. Technology advances are part of the spin-off of us being a species that is very interested in learning how our universe works and being very interested in manipulating how the universe works to our own advantage.
It's interesting to be alive in this particular time in human history. I mean, I'm sure every generation has felt like it was living at the top of the technological curve. We've advanced so far. We've done so much. We know so much. It's so amazing. And then 100 years from now, they'll look at us and probably laugh at how much we did not do and how much we did not know.
Right.
But we are really genuinely alive in a time, and we are seeing a connection of the world by technology and an outreach into places that we never thought we'd see, never thought we'd examine. It really is an amazing thing.
Absolutely. I mean, you just need to go back, say, a couple of decades to the early 90s. At this point in our understanding of our place in the universe, we thought we were a lonely solar system. We thought the universe was a largely empty place. We didn't really have a very good grasp of how the universe had started and all of these things. Fast forward to today, and in our lifetime, we've discovered that our universe is, our solar system is not alone. There are billions of solar systems out there. We've discovered a fundamental particle that brings together our entire understanding of particle physics, the Higgs boson. We've discovered dark energy. We know that we're embedded in this unknown background of dark energy. And then just recently, we detected gravitational waves for the very first time. I don't think there's ever been a time in human history where we've had such a rich period of discovery of such fundamental parts, fundamental components of our understanding of our place in the universe is absolutely incredible. And I do take your point that every generation is going to think that they're at the forefront of technology, and well, of course they are. But
No. I mean, if I'm going to qualify that, I will say that I believe that we are seeing an exponential leap. We're seeing a ramping up. We've discovered more in the last 100 years, arguably, than we have in, 1,000 before it.
Yeah. Absolutely. But the small steps that we had in the early part of the development of our species were important steps. I mean, going from no fire to fire, going from no wheels to wheels. I mean, these are big steps, and they happen very, very slowly. So yes, the exponential increase is we are seeing that right now, and it's very exciting. So the next 100 years, it could really, really change the direction of the evolution of our species. And you see a lot of science fiction authors and science fiction shows talking to this, right? So in 100 years, I would be very disappointed if we didn't have a permanent colony on Mars, for example. This is something that we're definitely working towards now. And so, one of the arguments for going to, many of the arguments for going to Mars are simply from the technology driver's point of view. Forwarding our understanding of how to live on Mars would also help our understanding of how to live on the Earth as well.
That's a one-way ticket, right? If you colonize Mars.
It depends how much money you want to spend.
Been nice knowing you,
Yeah. There are certainly people that are prepared to spend the rest of their lives out on Mars. Whether or not that's the type of person you want to send to Mars in the first place for a successful mission, we don't know. But
stop the world, I want to get off, right? You're going to send them off on a mission.
Yeah, to bring people back from Mars kind of adds an order of magnitude to the cost. Because if you give them a one-way ticket, you only have to do half of the mission, right? You don't have to figure out how you're going to get back off of the surface of Mars. You don't have to figure out how you're going to survive for even longer in the interplanetary space and all of the things like that. Yeah, it's something that we study down here in Florida because Buzz Aldrin moved here recently, and he's really gun-ho about getting to Mars. Yeah.
Did you see The Martian, Matt Damon?
Yeah. I read, of course, I'm an intellectual. I claim to be an intellectual, so I had to read the book first.
You read the book, then saw the film. Your thoughts?
Fantastic. Absolutely brilliant. I love first of all, I love the way Andy Weir actually wrote his book, right? He released it piecemeal. And then essentially he almost crowdsourced the material. And a couple of weeks ago, I was hanging out with the guy that actually helped him write the chapter in the book where he talks about growing potatoes in the dirt on the surface of Mars. And that's actually something that we're actually trying down here, is to take simulated Martian dirt and actually try and grow food in it.
I like the fact that it's a science fiction story that doesn't insult our intelligence. I mean, of course, we're going to suspend disbelief for going to the movies, but I was complaining about other... like Armageddon was on Netflix the other day, which, I know it's Michael Bay. I know. Don't send me the email. Don't send me the comment. But, at some point they push us to suspend so much disbelief that we disconnect from the story. Realism actually sort of pulls us forward. The Martian did a great job, in my opinion, of doing that. Yes,
absolutely. And amongst my colleagues, we're critical by nature. It's the way the scientific method works, is to criticize new ideas and see if they stick. And there were very few criticisms from the scientific community about the Martian. The only one was the storm at the very beginning. Oh, I suppose we ought to mention some spoilers, I guess. Never mind.
Yeah, if you haven't seen it, it's not. Yeah. I don't think that qualifies. I think we're safe. All right, the storm at the beginning didn't pass muster.
It's far bigger than any storm we've ever seen on the surface of Mars, and so that was the only criticism. But you've got to start the story somehow.
Talk to me about what you do. What is an astrophysicist?
So an astrophysicist studies the universe and then applies the principles of physics and mathematics in order to get a really fundamental understanding of what's going on. So I often get asked what's the difference between an astronomer and an astrophysicist. So a good example is when we just talk about the properties of a star. So an astronomer will tell you where the star is, give you some coordinates to the star, tell you what color it is, whether it's hot or cold or things like that. and then maybe even tell you how far away that star is, which is actually quite a difficult thing to do in astronomy because we can't just take out a tape measure and do that, right? An astrophysicist will take that information and then apply all of the fundamental physics we know from the studies we've done here on Earth, and then figure out exactly how long that star is going to live, what that star is going to turn into when it runs out of its fuel, whether it be a white dwarf, a neutron star, or a black hole, and actually what chemical elements are present in the star, the hydrogen, helium, carbon, nitrogen, oxygen. These are all very important things for understanding, how life can arise in the first place, right? How you can even get a rocky planet like Earth. So professional astronomers nowadays are really astrophysicists. And I try and push people towards saying astrophysicist because astronomy often gets mixed up with this unavailing exercise of astrology, which is something that we don't want anything to do with, of course.
Let's get philosophical here for just a moment. You are, eyes facing outward into the cosmos. And for many, this is an opportunity to find God, to find evidence of a supernatural hand. Have you had those discussions in your own life? What's your take?
So I get asked these questions by the general public fairly often. Myself, I would say the first truly scientific thing I did was when I was about 12 years old. And that is, I went to read the literature. So in England, there's very little pressure to be religious. And moving to the United States was a real eye-opener for me of how far the religiosity has actually ingrained itself in the culture here. But back in England, growing up, going to church is almost it was almost a habit rather than something that was taken seriously. But there was a community there, and my parents had friends there, and so they would go down to basically hang out with their friends, and that was fine. And there were kids groups that we would go to, and they would talk about these stories and that story. So at the age of 12, I thought, great, I will do what I think is the right thing to do, which is go and read it for myself. And I got halfway through Genesis, put it down, and said, this is clearly not making any sense.
You can say bullshit.
On the show.
Yes,
You can just say
okay. This is clearly bullshit. This creation myth is clearly false. The explanations of 900-year-old men buggering about in boats is crazy. Clearly this is not true. And at the age of 12, I just put it down, and I thought, there's no way a thinking person can possibly believe this stuff. And my parents didn't say a word. I just said, I'm not going to church anymore, and they were fine with that. And then so I just happily carried on without worrying about religion until, drum roll, I moved to the United States.
Now, where do you live now? Are you based in Florida? Or
Yeah, I live in Melbourne, Florida.
Okay, so you got Jeb Bush down there. You got a highly religious political climate going on as well.
Right, yeah. So we're kind of insulated around this area because we're close to the Kennedy Space Center, so there's a lot of private space contractors that work here, a lot of engineers and stuff like that. But as soon as you step outside of this kind of intellectual haven that we have here, you are driving up I-75 is a real distressing drive with the number of billboards you go by as you get closer and closer to Tallahassee. I mean, quite frankly, these are billboards that I never want to have my children to ask a question about. I mean, they put.
Well, yeah, honestly, though, Dan, if we have a scenario where the child asks the questions, it helps if the father is an astrophysicist who can actually sort of help put all this. I mean, I don't mind the questions, but the fact that many of these messages are being pitched as truth with a capital T does present a problem. But when you look out back to the sort of the cosmology of it, when you look out, many people say, look how vast, look how amazing, look how complex it is, how mysterious, how much we do not know. This becomes an argument for a higher power. You don't see a higher power. You see natural processes that, at least so far, can be explained. Yes?
Yes, we have a very good understanding of the evolution of the entire universe up to today after the first 10 to the minus 40th second after the Big Bang. So the pocket of ignorance that we have is the tiniest fraction of the age of the universe. That it does put all of these conversations firmly into a philosophical regime rather than a scientific regime. Science can take 10 to the minus 40 seconds after the Big Bang and explain everything up until where we are today, with the exception of abiogenesis. How do you get complex molecules to form DNA? We don't yet know that. So these are the two regions where somebody who is arguing from the God of the gaps point of view, these are the two little gaps that they have. A tiny little bit of information about how long chain molecules form into DNA, and then a little bit of information on the first 10 to the minus 40th second after the Big Bang. So that's a decimal point, 40 zeros, and then 1 second, right? That's a very tiny pocket of ignorance. To then introduce the argument that there is a creator that did that just makes it even more complicated, because then you're left with the arguments of, well, who created the creator? What does this all mean in the first place? And those are arguments that do get presented to me. And quite frankly, I take the Occam's razor approach, which is your explanation is far more complicated than any of the explanations that we've come up with for describing any of the processes that we've seen that we have experienced and have seen in the universe in the first place.
Well, that brings me to my next question. Many people say that complexity, the fact that there are so many millions upon billions upon trillions upon squillions of gears in the machine, proves that it is design. And I heard someone, perhaps it was an actual engineer, say that the best designs aren't the most complex. The best designs aren't necessarily the ones that are the most complex, but are the ones that reduce all of the sort of the superfluous stuff and become more basic. Is there any merit to that, Dan?
Well, I think in general, people have an unintentional ignorance about exactly how big the universe is, how much stuff there really is in the universe, and what the word complexity actually means. Because complexity is something that you can put on a scale, right? There can be something that appears to us to be really, really simple, like describing why a ball falls towards the center of the earth, right? Because well, maybe that's not such a good example, but just understanding how something falls, very straightforward explanation. If you want to understand the physics of a star, really, it does boil down to a fairly simple set of explanations. And this is one of the things that motivated me to write this book, is it just needs to be explained in a way that can be brought back to everyday examples, brought back to a level where you don't need a Ph.D. in astrophysics to understand these things. You can take very simple explanations and apply them to seemingly complex systems to find out that the complexity is not actually there. So I'll give you an example of understanding how a star works. A star is basically a balancing act between two forces, the force of gravity and then the force of all of the nuclear explosions that are taking part inside the star. The nuclear explosions need hydrogen, and they're using up the hydrogen. So when it runs out of hydrogen, there's no longer a balance, and the star collapses under its own gravity. If you want to have a full senior level astrophysics class on the physics of stars, then you deal with the details. But the details are only going to explain things that are really inconsequential, right? It's for the everyday understanding of our place in the universe. You don't need to understand the complexity. The fundamental things that we know about our universe are not complex. We know that we don't live on a flat Earth. We know that the Earth is 4.5 billion years old. We know that we are a solar system amongst billions of other solar systems. And we know the universe had a beginning and how old it is. All of these things are incredibly profound, but none of them have such a complicated explanation that you need a graduate degree or a bachelor's degree in astrophysics to appreciate them and to understand them and to realize how humbling they are. and to realize how inspirational they are, and to realize how all of these facts about our universe actually bring us together as a species without any regard for our differences about our demographics. And so this is the core thesis that I put in the book, is that we really should be teaching 12-year-olds astronomy. We really shouldn't be teaching them appreciations of religion, right?
I want to get to the book. It's called Astronomy Saves the World is the book.
Yes.
I'm coming to that. I've got an astrophysicist on the line. I have questions. I'm taking advantage of it, right? You can bill me.
No problem.
I've heard it often asserted that the universe began with a mass or something about the size of a fist or a ball or something. I have no idea what they're talking about. Can you speak to that? The universe began like this, and then it propelled outward in this massive explosion. Educate us.
Okay, so first of all, when these analogies are made, they're made from the point of view of us as three-dimensional beings, understanding up, down, left, right, forward, and backwards, right? When you hold up an object and say the universe started as a fist, you have to realize that if you were in that you're in that universe. You are not something that's external looking into that universe, because that contradicts the definition of the universe, right? You end up asking a ridiculous question, a question that doesn't really have an answer, right? And I think there are several examples of ridiculous questions, like what does the number 7 smell like, and things like that, right? Yeah, I think you probably are familiar with many of these examples.
Heard a few of them, yeah.
Yeah. So if we want to describe the early conditions of the universe, yes, there is a point in the past where the universe would have had an observable diameter about the size of a fist. But that is not the end of it by any stretch of the imagination. You can make it smaller and smaller and smaller and smaller and smaller and smaller and smaller. You can take it back to the size of a proton if you really wanted to. And we understand the physics up until around about that scale. And so really it's not about the scale of a fist. It's much more further back than that. Now,
but how's this determined, Dan? How do you get there?
Okay, so the explanation we have for the past history of our universe is actually a very good example of how the scientific method works. So it all starts back with Edwin Hubble. So he was observing galaxies, and he was trying to figure out how far away they are. It's a very difficult thing to do. And he found a method of figuring out how far away they are by looking at a particular type of star. He also found that the galaxies appeared to be moving away from us. And so he has two pieces of information. Hubble. He had how far it was to the galaxy and how fast those galaxies were moving away from us. And this is what we do as astrophysicists all the time. We have two pieces of information, so that's all we have. Let's plot them against one another and see what happens. And you have to be careful about causation and correlation, but when Hubble plotted the distance to galaxies and how fast they were moving away from us, he found a nice relationship. On average, the galaxies that we see moving away from us are moving away from us faster the further away they are. Now, this may appear to put us in a privileged position in our universe. If everything is moving away from us, then we must be at the center of the universe, right? In a three-dimensional understanding, sure, you could think that, but the universe is not three-dimensional. It's actually an analogy we use is to take our three-dimensional understanding of the universe and apply it to what a two-dimensional creature would experience. So we say to people, you can't think of it like a three-dimensional object. You have to think of it like us living on the surface of an expanding balloon. Take any point on that balloon, put some dots around it, and blow the balloon up, and you will look like you're at the center of that expanding balloon, but you're not. You're just on the surface of it. So this is the first piece of information we have about the history of our universe. It's expanding now. Just turn the clock back. It must shrink if you turn the clock back. So it goes smaller and smaller and smaller. All the galaxies get closer and closer and closer together. So what's the second piece of evidence that we have for this? Well, the universe is full of particles, right? Protons, neutrons, electrons, neutrinos, all of these cool fundamental particles, right? At some point, we have to get all of the more complicated particles like helium, carbon, nitrogen, and oxygen, and all of these things. And when we look through the universe, we see that there's actually more helium present in the universe than there really should be. The only way to do that is to take the universe back to a point in time where it was so hot, the entire universe was so hot, that the universe itself could process hydrogen into helium, because normally that process takes place at the centers of stars. So now we've got two pieces of evidence to say that in the past, the universe must have been a lot hotter, a lot more dense. So now we can make a prediction. Can we see something that confirms our prediction that in the past, the universe was hot and dense? And we do. You can tune radio antennas to hear the noise. Well, it's not noise, but you can tune a radio antenna to actually detect the hot, dense past of our own universe. So we call that the cosmic microwave background, right? It's a very good description of what it is. It comes from the entire cosmos. It's a background, and the wavelengths are in the microwaves. You can actually tell how recent a piece of scientific understanding was by how simple the description of what it is. So if you go back to Newton's times, you'll have to remember Newtonian mechanics, right? That doesn't really explain what's going on. And if you come further and further and further back into where we are today, we've simplified our explanation of things. So we say cosmic microwave background. It explains exactly what it is. So we've got an example of two separate observations that make the same prediction. We go and look for the predicted signal. We find it. This is absolutely concrete evidence that in the past, the universe was a lot hotter and a lot denser. So now what do? We try and reproduce in our own part of the universe the conditions that were found at the very early times in the universe. So this is why people dig big, long circular trenches and smash particles together, because the energy of the collision of those particles reproduce the conditions that we had very, very early on in our universe. And so it's experiments that go on at Fermilab outside of Chicago, and that go on at Geneva and CERN. These are the places where physicists are reproducing the conditions at the beginning of the universe that actually allows us to take our understanding further back than just the fist.
It's interesting. I stumbled upon a documentary called Particle Fever.
Okay, yeah.
Where they were sort of chronicling the quest for the Higgs boson, and it's amazing how they could make such, in many cases, clinical information sort of dramatic and exciting. We were leaning toward, no, I hope they find it. I hope they see it. And I'm sure some of that's manufactured by editing, but it was an interesting story to tell. And I think it's worth a look. It's called Particle Fever. One more real fast before I get into the book. Recent headlines about this Einstein thing, right? The ripples in space-time, the detection of gravitational waves. What are we talking about, and why is it important?
So this is a real privilege to be around when the direct detection of gravitational waves was reported. So gravitational waves are a prediction from Einstein's theory of general relativity. Essentially, when you have a large, dense object moving through the universe, is going to affect the fabric of the universe. And it does it in a very, very, very tiny, tiny way. Now, when two of these objects are in orbit around one another, they're going to create a huge boost in the size of these ripples. So these ripples are the gravitational waves, but the analogy we use is like the waves on an ocean, but really what it is, it's a compression and stretch of space. So this is going back to the difficulty in disassociating ourselves from a three-dimensional universe and putting ourselves in a four-dimensional space, right? Space-time, is that the effects of this wave is to do a compression in one direction and then a stretch in the other direction, and for that to be cyclical. So we now know that we're experiencing gravitational waves all the time. This is one of the results that was announced just recently, because we have detected it directly. And it's the same type of thing, the same type of profound understanding about our universe that we had when we first directly detected the predicted cosmic microwave background that we were just talking about. And so how do you detect these waves? It's a very tiny effect. So you have to build, as usual, a very large, expensive instrument to do this. And that's what's been done. And they're called the LIGO detectors. They're actually on either sides of the continental United States. So you have two independent detections of the same event to make sure you know that one detector wasn't just being blippy that day. You get the signal in both detectors. And these detectors are essentially mirrors that are spaced apart by two and a half miles or something like that. And in between the mirrors, they're firing a laser. And the mirrors are suspended on a pendula. So the mirrors themselves don't move relative to one another unless there is a compression or stretching of the space in between them. And so in September, the LIGO, September of 2015, the LIGO experiments had a coincident detection of the same event. They got the same signal at both detectors. They mapped them onto one another, and then they run a bunch of simulations to determine what produced that signal. And what produced that signal was two spiraling black holes of 30 times the mass of the sun each. They came together and merged into a 60 solar mass black hole. And in that process, the missing mass between the two original black holes, that mass gets converted into energy, and that energy goes into the gravitational waves. So these gravitational waves actually originated from a binary black hole that spiraled in that is 1.3 billion light years away. So by the time these gravitational waves got to us, they had been smoothed out by traveling through 1.3 billion light years of space. So the actual detection at the LIGO instruments is mind-blowing, absolutely mind-blowing. What's going to be really interesting is, I think, very soon they're going to announce another detection, which is really going to change the way we can investigate our own universe. Up until now, the only real way we've been able to investigate our universe is by looking at photons, the light from objects, occasionally the particles in terms of cosmic rays, and then sometimes lumps of rock fall to Earth. So we've got meteorites. Now we have an entirely new way of studying our universe, and that is basically in the way our universe is. It's almost vibrating. It's being caused to vibrate by these things. And so, this is just another example of one of the profound findings we've had about our understanding of the universe in the last 30 or even 20 years. Absolutely astonishing.
So was Einstein just guessing? I mean, he didn't have these instruments. I mean, how did he get there? Was he doing some kind of math? I mean, what happened?
Right, exactly. He was doing some kind of math.
I mean, you can tell I'm a complete idiot on that when I say, was Einstein doing some kind of math? Yeah, you know what you're just speaking to, Dan.
So this is the other important point about the detection of gravitational waves, the direct detection of gravitational waves. Not only does it open up a new way for us to investigate our universe, it also confirms yet again the genius of Einstein. So Einstein, with his theory of general relativity, came up with a whole bunch of equations that are really difficult to solve. So difficult that we basically get computers to solve them. We tell the computer, hey, here's a really difficult problem. Keep guessing. And if you get an answer that makes sense, tell us. And we'll look at that answer and see if it makes any sense. And that's what that we call that numerical simulations. You basically just guess a whole bunch of times and see if something sensible comes out. So Einstein's equations, to actually get the real details of gravitational waves and to see the effects that they have, you need to solve those equations. But you can predict that these waves should exist just by looking at the equations themselves. You don't need to solve them in order to predict the possibility of gravitational waves. So back in 1916, 100 years ago, the theory of general relativity was put out. We should be careful with that word, theory. The fact of general relativity was put out. The predictions was that there were gravitational waves. Einstein knew that the technology needed in order to detect these would never come about in his lifetime. It's come about now. Einstein is proved right once again. Absolutely brilliant. And so it's no coincidence that we're making these findings and that our ability to process a lot of information is increasing. So our technological advances in computing have been one of the reasons why we've been able to make these observations.
You're a great communicator. I mean, just across the board. But when it comes to scientific things, you're able to make it palatable for the rest of us. And I have no doubt this translates into this book that is coming to fruition. So tell me what it is. Are you targeting young people? Is it for everybody? Is it, what is this thing?
So the book is written from the point of view of the reader not having any background in science or mathematics. So
I'm at a bookstore, I see it, I pick it up, and I can play along.
Right. Yeah. But you have to start at the beginning. It builds on itself, right? The chapters, some of the chapters stand on their own. The introduction and the final chapter stand on their own. But in between, I bring the reader through all of the basic mathematics and physics that allows the reader, by the end of the book, to have an appreciation of how you demonstrate the Earth isn't flat, how we know the distance to the moon, how we know the age of the Earth, how we know that we're made of stardust, how we know that there are other planets outside of our own solar system, how we know that the universe had a beginning. The introduction of the book is setting up why having these understandings is important. And so the introduction of the book takes the reader through a brief history of our understanding of our place in the universe, and then provides the reader with a what I call a pocket-sized baloney detector. And so Carl Sagan talked about this baloney stuff. It's actually a chapter out of his book, the Demon-Haunted World. And he basically goes through all of the logical fallacies that there are. And there are over 100 logical fallacies. And neither you or I, well, maybe you are, but I am not in a position to learn every single logical fallacy and understand all of the intricacies of that logical fallacy and then have it as armor against anti-intellectualism. So I've broken down the baloney detector into a pocket-sized baloney detector that just says, hey, if you think that it's bullshit, it probably is. And this is the way you can sense that it's bullshit. If you feel that somebody is making something up, they probably have. If they don't have a full explanation of something, they probably don't have a full explanation that makes any sense. If you feel that you are being insulted, if you feel that you're being threatened, then these are all indications that what that person, the information that person is presenting to you is bullshit. And so I basically break it down into lies, threats, and personal insults. When I first started writing the book 2 years ago, it was lies, threats, and insults. But in the last 2 years, we've seen this inversion of what it means to be insulted or threatened in this kind of cry bully society that's coming that seems to be rising, right?
Yeah, they play the martyr and then they go after you. Usually, I think if you hear the ad hominem attack, you know you're probably onto something.
Absolutely. And yeah, and sometimes people don't even realize that they're being insulted. So that, because, you know, religion comes at you in this kind of ingratiating way that it's kind of some religions, right? Not all of them, but some of them come to you in this kind of, well, you know, you're probably better off coming to our club and hanging out with us and doing all this stuff. And, you know, don't you want there to be something bigger and better? And that to me is an insult. It's that person is saying, you clearly don't have a better explanation of what's going on. You clearly need some moral guidelines given to you by us.
Yeah, they're speaking in a superior way to an inferior person.
Right. And so, this, some people don't realize that being good for goodness sake is far more virtuous than being good in some hope of reward or fear of punishment. But the next thing that the evangelicals would try, perhaps, is to then get that person to say, okay, where did the universe come from? How old is the Earth? Because if you don't have an explanation, we do have an explanation that's very easy for you to understand. And that is, God did it.
This provides a resource then for people to be able to understand the basics of, digest, and then relay to other people the answers to many of the questions that they are receiving on the front lines in these sort of apologetics arguments. How do you know? How did it happen? Has it been measured? Can you prove it? Those types of things are addressed in your book. Can you give me just a few chapter titles, just some of the things you're tackling?
Sure. So chapter 1 is called The Troubles, the Struggles, where we go through what we just discussed, the struggles that we've had to understand our place in the universe, and then the troubles that we get from the human factor, which is, people saying, well, if you personally can't describe to me why we know the Earth is 4.5 billion years old, then clearly that's not true. But I can quite clearly articulate to you why you should believe there is a God. So that's what we call the troubles and the struggles. The second chapter is called Astronomers Are Really Good at Staring, because that's the only way we can. It's quite creepy. All we're doing is we're staring really intently at our universe, and this is you can't do this to every person, right? People get weirded out when but astronomers are staring at the universe, right? And that's the only way we can determine what's going on in our universe. It's not like a chemist, right, that can change the salinity or the pH of a solution to see how the system reacts. We just have to wait and stare and see how the universe changes with time, changes with wavelength. And now we have gravitational waves, of course. That's one of the exciting things. One of the chapters is called A Close Shave or a Punch in the Face. And this is describing the threats that we experience from, the potential threats that we experience from near-Earth asteroids. And one of the things I'm quite clear to point out in the book that is essentially there's no longer any threat from near-Earth asteroids. We have currently, we know of 97% of all of the asteroids that could cause a catastrophic calamity on the surface of the Earth if they were to impact them. And we do have the technology to go out and save the world by getting a spacecraft to these asteroids that are potentially going to hit the Earth, getting to them early, and just giving them a very gentle orbital nudge. Because if you get to them early, you only need to make a very small correction to the orbit of that thing to make it miss the Earth by a lot. And then, of course, these asteroids are going to be our stepping stones to allow our species to expand throughout our solar system and perhaps beyond. So another chapter of the book is called Rock to Rock, where I explain how humanity can use the resources in our solar system to start expanding ourselves off the surface of the Earth. Because no matter how we cut it, the Earth isn't going to be here forever. And I suspect most people really want their descendants to have some success in life. And just ignoring the facts about the future of our Earth, not just from a resource depletion point of view, because you can have some arguments about, we're probably not using all of the resources on Earth in a very efficient way to provide for the population that we have. But simply from the point of view of our sun is going to die and there's nothing we can do about it, despite what they say in the movies, right? There's one sci-fi movie where they go and try and spin up the sun or something, or reignite nuclear fusion in the sun. What's that one? Solaris or something like that. But anyway, our sun's going to run out of fuel. It's going to actually start to expand. It's not going to happen for billions of years. And we could hang around as humans and wait and be reactionary to that, or we could be proactive and start doing it now. We've got the technology. We've got the knowledge. We can start doing it now. We should start doing it now. And then the final chapter of the book is called Emancipation via Education. And this is where I put forward my thesis of, if everybody in the world understood our place in the universe and could describe and protect themselves against the intellectualism and describe how we know our place in the universe, that is going to move people into a more realistic worldview, a worldview where we are one species struggling to survive in a very hostile universe, rather than just a bunch of individuals trying to get rich and trying to have a good time. We need to realize that our place in the universe actually brings us together, binds us together, and we should try and use astronomy, use our understanding of our place in the universe to try and instill into people this appreciation. And I want to avoid giving the impression that I want to preach to people, but we're not making this stuff up. This really is the truth, and we can prove it. And that's the difference.
I had first become aware of Dan's work after he had done a presentation at the Florida Free Thought event in the fall of 2015, and really thought it had merit. And I'm very glad to have you here on sort of the radio and doing the video podcast, because, I think people are hungry in many cases to learn. They're just intimidated and overwhelmed by the enormity, the complexity. They don't speak the language of astrophysics, blah, blah, blah. You and your work, the work of people like you, making it palatable, allowing us to engage in these types of conversations. And that's why I would encourage our viewers and listeners to support the book itself, which is still coming to fruition and is being crowdfunded in some way. Can you kind of flesh that out very quickly? And I'll include a link in the description box of this show, because I'd like people to go and toss a few bucks Dan's way. And then I think, give me a release date again for when you want to see this thing finally hit.
The book is scheduled to be coming out in July, in the summer. It's written, and half of it, or a good portion of it, has already been edited. I just need to have the editor go through the last few chapters. We've got a publisher standing by. We've got everything we need except the support of the community. And so the crowdfunding has been set up through Kickstarter just to help quite literally kickstart the book. It was quite interesting after the first manuscript was finished. I took 2 years to write the book, weekends and evenings. So I'm thankful that my kids are good sleepers, because as soon as they're in bed, I was coming down at 9 o'clock every night and doing a couple of hours work for the last 2 years on it. But the publishing world is, I was really surprised that when I started looking into the world of publishing.
In many ways, it's a closed system, right? You have to already be successful to sort of get a place at the table.
Right.
And yet, crowdfunding and using the internet and other publishing options are allowing authors who have something to say to be a part of the conversation. I love the information age, man. It's just awesome.
It's absolutely brilliant. And that's the advice I received when I started sending the book around literary agents. They were saying, you're new, you have to self-publish. You have to self-publish to get your foot through the door. And so that's what I'm doing.
What exactly does the funding support? Is it the production of the actual physical book? Is it advertising costs? This is something that most people don't consider. They think, once you published a book, you're done. When 80% of the work that happens after publication, you're just trying to get it in front of the people you're trying to reach. And that's much harder than it looks, and often not cheap.
So with the Kickstarter, there's several things that I'd like to achieve. The first is actually receiving feedback before the book goes to print. So I'd like, I'm looking for some people to actually be beta readers of the book, so that before it goes to print, it's actually been run by 20 or 30 people who I'm aiming the book at, and they can give me feedback to say, you need to clarify that. I don't get that bit. Please help. Please fix it. So I want to fix it before it goes to the printers, and that is where most of the cost is. Most of the cost is actually in having the hard copy printed itself. I'm all for reading physical books. I do have my own e-reader because you get less crap on the plane when you're reading an e-reader than holding up God Is Not Great, right?
No, I get it. I love digital books as well, but when you do it digitally, you don't get the trophy wall. You don't get to look up at a book and go, oh, and then hand it to someone else and say, you got to borrow this. It's amazing, that kind of thing.
So, but I'm also doing the digital version as well. So the digital version would be released a little bit earlier. That's basically, I'm trying to do everything at cost. So the costs go into the printing of the book, the shipping of the book, and then some of the other things that I didn't realize you need to pay for books like the ISBNs and
nickel, dime. I totally get it. We talk a lot in this movement about the need for science education. And yet it's not all that often we have opportunities to actually be a part of bringing science education to other people. Are we just lip service? Are we just going to sit in the corner and bitch and moan about the creationists and the anti-science propaganda? Or are we literally going to get behind people who are promoting legitimate, peer-reviewed science out there and allow them the opportunities to bring that education forward? We aren't astrophysicists, but we can certainly support someone who's done some amazing work. And I thought Dan's project had merit. I would encourage our people to get behind it. And is there a website? Is there any place people can go deeper yet? Or is that all still coming together as well?
So I've put out the introduction to the book and the first chapter. It's already available for people.
All right, so they can get a taste of it. That's kind of what I was looking for.
Yeah, it's available to read at danielbatcheldor.com.
I'll include that link in the description box of this broadcast. My friend, you're a great communicator. No wonder they had you on stage in Florida. You're just really good at putting all this stuff together. You've been a compelling and entertaining guest, a great educator, and we'll do our best to see if we can send some resources your way. When it comes out, we'll make a big splash as well so we can get this out to the people that we know in our circles, okay?
Fabulous. Thank you very much, Seth.